Hey everyone, in this video I'm going to show you how to take a model built with tidymodels, use it to make predictions for our in-class Zillow price range property classification challenge and submit predictions so that you will show up on our leaderboard. So let's get started. We're going to start I have an R script or a Quarto document. It's very plain. We're going to set up our environment, read in our data, split into training and test sets, build cross-validation folds. We'll then build a model. I want to keep this simple, so this video should stay simple. And because of that, I'm not going to really run cross-validation. I'm not going to tune this model, but I will remind you about cross-validation and tuning when we get to the appropriate spots. I'll remind you about how to run those procedures. And then our focus will be, after we have a fitted model, using that model to make predictions on our competition data, and then taking that model's predictions, extracting them into a CSV file, and uploading them to Kaggle for scoring. So let's get started. Again, this is a very plain document. There's no discussion in here. There's no exploratory data analysis. You will have already started all of those things through your first few competition assignments. So I'm going to start by loading the tidyverse, loading tidymodels. These are packages in R that we use quite often. Basically, every time we've been opening up R, we've been loading those two libraries first and foremost. I'm also going to start by reading in my data. So you can see that inside of this project, so one thing you all want to make sure of is that you're in the project that houses your competition assignments for our course. Most recently, you've moved to new repositories. So you're going to use this drop-down menu. Underneath your recent projects list, you should have the ability to swap back to that old project environment. Inside this project environment, so inside the home area, I have a file called comp.csv and data.csv. I downloaded those from our Kaggle competition. You already have those files and you've been working with them. So here they are, comp and data. Heading back to R, we are going to read those files in. Once we do, you can see they show up in our global environment. We're going to split our available data into training and test sets. You'll notice a difference, by the way, between the data and competition files. They have different numbers of rows. That's not a surprise because these contain different properties in them, but they also contain different columns. And that's because the data set has the price range column, and the competition set is missing that column. So your job is to build a model that's going to predict that column. And so we'll see what we can do here with that. So I'm going to set a seed for reproducibility. I'm going to use initial split. I'm going to stratify also those splits by price range. I just want proportional representation for that outcome class category across all its categories in my training set and my test set. So let's run. We're going to set the seed for reproducibility. We'll split our data, create training, create test sets. These are things, again, that you've already done. We're also going to, even though I'm not going to run cross-validation here and I'm not going to run model tuning, we'll split our training set into cross-validation folds. I'm going to set a new seed to do that. That's unnecessary, but it is safe to do. And then I'm going to use vfold cv to create training folds. By default, this is going to create 10 folds. You can keep it at 10, you can change it to 5, you can use any number of folds that you like. Just remember that the more folds you have, the slower this assessment process and tuning process will be because you're going to be fitting more and more models. I'm also going to stratify here by price range for the same reason as we did it with our training set. Now that we have our data split, let's go ahead and let's build a model. I'm going to build a very basic decision tree. I don't want this tree to do very well. I want you to be able to crush it quite easily. So keep that in mind while I'm building this. So we're going to start with a model specification. So I'm going to do DT spec, and I'm going to call this a decision tree. So this initializes a decision tree model. We're going to set the engine to R part. This is the default engine for decision trees. And we're going to set the mode, because decision trees can be used for both regression and classification, to classification. And we'll run that. Now we have a model specified. We're also going to build a recipe, so dtRes is a recipe, and remember, recipe contains your formula. So we're going to try to predict price range. And I'm going to use just a few predictors here. I'm going to show you, though, we've in class been using this dot notation. Data equals train is where our or tidymodels can go and look for the columns that it has access to. One of these columns, though, is description. You do not want to use this column just yet. Description is a unique identifier. It's a non-numeric column. If you try to use it and you use step dummy, you are going to create a very, very wide data set because all of these descriptions are unique, and that won't be good for you. So we're not going to use the the description column just yet. You can get rid of it, again, by using step rm for remove, description from your model. But for me, I want to build a simple, relatively simple model. I'm going to use just a couple of predictors. I'm going to use lot size in square feet. And I'm going to use, let's say, number of bathrooms as predictors. And I'm going to do a couple of things here. So number of bathrooms, I'm going to treat as categorical. So I'm going to do step mutate num of bathrooms. And I'm going to use as.factor on this. So this will create this will convert that column into a categorical column with known levels. So num of bathrooms is going to go there. And now that that's a categorical predictor, I am going to have to get dummy variables for it. I'm also, though, just before we get started, going to impute any missing values. So I'm going to step impute median for lot size square feet. And I'm going to step with categorical variables, there's a couple of things that we want to do here. It is possible that we could observe new levels when we run our model. So we could do step unknown on this num of bedrooms column. This, if I get a missing value, I'm just going to convert it to an observation or a record called unknown. Then we can do step novel. Step novel will take a previously unseen category and handle it. It'll put it into a category called new or novel, so that our model doesn't break by seeing a new category. And then we're going to do step other, which will take small, infrequently occurring categories and just group them together. And we're going to do that also with our categorical variable. And I think that's all we'll need to do. We'll come back here again if we need to. Again, we're going to predict price range using lot size in square feet and number of bathrooms. We're going to use number of bathrooms as a categorical predictor. With our numerical predictor, lot size in square feet, we're going to impute any missing values using just the median for that column. For the number of bedrooms column, if I get something that's missing, I'm just going to convert it to unknown as a category. If my model sees something new at prediction time, I'm just going to convert that entry into a category called novel. And then what I'm going to do with all of those categories is anything that is a relatively rare category. I think that step other uses 10% as a default. We can check it really quick. So threshold value from 0 to 1. It's not telling me what my default is. Default is 5%. And so any category that occurs with less than 5% frequency will just be grouped into a new category called Other. And then there is one more thing that we've got to do. Sorry about that. We've got to convert to dummy variables. And num of bedrooms here. We've been using all nominal predictors in these scenarios, but because we just have the one variable, it doesn't make any difference to use the variable name instead. So we'll build our recipe, and now we'll package that recipe into a workflow. So we're going to add our model, dt spec. We're going to add our recipe, dt res, and build our workflow. As a reminder, we are just fitting an out-of-the-box model here. So we're fitting a plain vanilla decision tree. Decision trees and all of the other model classes that we've encountered so far have hyperparameters that can be tuned. So for example, decision trees have a minimum n hyperparameter. So how small should a bucket be in order for me to prevent myself from splitting it further? There's also a tree depth parameter and a cost parameter that can be tuned. If you've set hyperparameters to tune, remember you cannot fit your workflow to data, and you cannot run cross-validation directly on it. You're going to need to tune that model using a procedure like tune grid for a grid search or tune Bayes for a grid search followed up by a sequential search, kind of moving around that best hyperparameter combination to try to find incremental improvements over it. But again, for now, we're not going to set anything to tune. We are just going to fit this model directly and see what happens. So I'm going to take dt and create a fit object. dt wf is going to be fit to my training data. So again, bypassing cross-validation altogether here just to get to the objective of making model predictions. Can't select columns that don't exist. Num of bedrooms doesn't exist. So let's check what's happening here. We've got num of bedrooms. Num of bedrooms. Maybe I spelt it wrong. Oh yeah. Num of bathrooms here. So all of these should be bathrooms. Sorry about that. Probably some of you were yelling at me through the screen here while I was building this recipe. All right, so now that everything's changed back to number of bathrooms, which is the predictor I originally said I wanted to use, let's fit that model. And we get an error again. And I can't spell either. Num of bathrooms. All right, that's better. So now we have a fitted model object. If we wanted to see it, we could. But again, our goal here is just to extract model predictions. So I'm not even going to assess this. This is all kind of bad practice, but again, I don't want to build a super long video. I just want to show you how to extract predictions. So at this point, what we're going to do is we're going to take our fitted model, dt fit. If you're going to do this, your model has to have been fit using the fit function. So remember, if you run cross-validation with the fit resamples function, what you're getting is a bunch of performance metrics. You are not getting a fitted model. If you run a tuning process like tune grid or tune Bayes, also, you're not getting a fitted model. You're getting a bunch of performance metrics and hyperparameter combinations. So after you've run those tuning procedures, what you want to do is select those best hyperparameters, set them into your workflow. So you're replacing the tune function with those values, and then fit your workflow to your training data so that you have a model that can make predictions. The way we're going to have our model make predictions is with a function called augment, and we're going to augment our competition data. And I'm just going to run this so that we can see what happens. So we get a bunch of new columns. We get pred class, we get pred 0 to 250,000, and a dot pred column for all of the other outcome variables that we had. We also have the original ID column. We have city, description, everything that was in that competition set. So all of these pred columns are new. What I'm going to do is head over to Kaggle and see what Kaggle would like from us. So I'm going to click on the sample submission file. And we see an ID column, then we have prob A through prob E. So what we're going to need to do is build a data set that has just these columns in it. And so those prob columns are the predicted probabilities of class membership. And I think inside of the overview, I've mentioned what should happen here. So the prob A column corresponds to the 0 to 250,000 group, prob B to the next group, 250,000 to 350,000, and C, D, and E get progressively more expensive. And so that's what we'll do here. So we'll head back to R. We don't want the pred class column. Remember, we do want, looking at this data, we want an ID column first, and then those predicted probabilities. So we are going to come back here and select. Remember, select is a function that allows you to pick out columns. The columns that we're going to select are ID. And then all of those pred columns, I'm going to use a helper function, starts with, and then dot pred. So this will identify all of the columns whose names start with dot pred. If I do that, though, I'm going to get this pred class column. So I'm going to subtract that column out, minus pred class. So this will remove that column. If we run this, we should just see the columns we want back. So we've got the ID, those prediction columns, and there we are. So what I'm going to do now is I'm going to rename the columns in here to pred A through E, and I'm going to use mutate for this. Actually, no, I'm not going to use mutate. I'm going to use rename. And then this syntax for this is new name equals old name. So the new names for these columns, I'm going to have prob underscore and then a letter. So prob underscore A is equal to dot pred 0 dash 250 zeros. Then prob B equals dot pred 250, 3 more zeros, dash 350, 3 more zeros. And then prob C equals dot pred 350, 3 more zeros, and then 450, 3 more zeros. You can see the text changing color here. This is indicating that probably we are going to have to use some sort of quotations around the column names because of this dash, that minus sign. So we'll deal with that when we get there. Pred D equals dot pred 450,000 dash 650,000, and then prob E is dot pred 650,000 plus. And I'm going to try to run this, but almost surely, again, you're probably noticing this blue font. This is indicating that I have a numeric value and I'm trying to run subtraction. So almost surely this is not going to be happy. And so, okay, unexpected closing parenthesis, and that's because of the subtraction happening. So let's try putting quotes around all these column names and see if that works. And if not, we'll use some backticks, which should work. Or we could go back to the beginning and use janitor to rename our columns into something more friendly. Okay, cool. So putting quotations around those column names fixed our issue. And now we have a data set that has 6 columns, the ID column, and then the 5 predicted probability columns. And we are ready to export this. So what I'm going to do is save this as comp with preds. So this will be a new data frame. And we can see up here in our global environment, it shows up, and we have our data frame with the ID column and the predicted probabilities. And now what we've got to do is we've got to write this file out to a CSV. So basically we want it to show up here as a new CSV file alongside data and comp. So R has a write.csv function. The first argument it takes is the data frame that we want to write out. So that's comp with preds here. The next argument it takes is the path to the file with the file name. By default, my file is going to go into my repository folder, the root of that repository. And that's fine with me. So I'm going to just add comp preds dt and maybe 1. To indicate that this was my first decision tree approach. And then I'm also, by default, R is going to write out row names with this. We don't want that to happen, so row.names equals false. And if we run this, we see comp preds dt1.csv show up. And you can open this if you want. Opening it there doesn't look very nice. If we open it in Excel, where are we? Here. We can see that we've got a table that has our ID column and then lots of predicted probabilities. This is ready to go to Kaggle. So we're going to head to Kaggle. We're going to click Submit Predictions. We're going to upload our file. So I'm going to navigate to it. GitHub, Mat34 Spring, and comp preds. We can enter a description if we want. Decision tree with lot size and bathrooms. Categorical for bathrooms. Maybe I want to indicate that. And submit. So now what Kaggle is going to do is it's going to look and validate that I have all my columns that it expects. It calculates a public score. So my score now is at 5.6 for my log loss. And if I check out the leaderboard, I don't think I show up there because I'm the host of the competition. But just with a basic decision tree that used 2 predictors, we were able to really beat that benchmark score by quite a bit. All right, I think that's it for now. So just as a recap, we started this video by setting up our environment, loading our libraries, reading in our data, splitting the data. Then we built a model. We didn't try very hard with this model. We built a decision tree. We just used 2 predictors. We used some step functions to change the way our model was going to use some of our features. We had a little bit of trouble as we went through this, just dealing with column names that I had mistyped. As you're going through your model construction, again, you may encounter similar things. You may encounter errors that are not just renamings or mistypings. So as you're encountering those, check out the error message. Feel free to post to Slack with questions that you have. Once we had our recipe, we packaged it together with our model into a workflow, and we directly fit our model. Remember that you're probably not going to use this strategy. You are going to explore hyperparameters and tuning. So inside your model specification, you may set some hyperparameters to tune. Inside your step functions, some of those step functions have hyperparameters that can be tuned as well, so you may try to tune those. In that case, you still package everything together into a workflow, but instead of using the fit function, you end up using, so we do something like tune results so that we know what we're storing, DT workflow, as long as that has some hyperparameters set to tune in there. You may use something like tune grid or tune base in order to have your model search over a hyperparameter space trying to find optimal hyperparameters. Once you do, you can reset your workflow to use those optimal hyperparameters, fit the model that uses those optimal hyperparameters, and then do exactly what we did below, which was to take our model, use it to make predictions, choose only the columns that we cared about, and then rename those columns so that they had the names that Kaggle expected. And then finally, we wrote out that file as a CSV, making sure that R didn't create a new column for row names that we would have to then remove by hand. All right, that's it. I hope you found this helpful. Please reach out with any questions that you have, but here is, again, how to extract your model's predictions and submit them to Kaggle. Thanks, everybody.